So when we're talking about ellipses, I'm going to give you the definition of an ellipse. It won't make any sense, but I'm going to show you a picture of that in action that has it all written out on there for you, and then hopefully it'll make more sense. Okay, an ellipse is like an oval, but that's not the definition of an ellipse. An ellipse has 2 points. It'll be on the screen in a second. It has 2 points. They're the same distance from the center, okay? And if you draw a line from those 2 points to the same point on the ellipse, then any point on the ellipse, and the sum of those 2 lines, those 2 distances, will always be the same. Which again, probably doesn't make any sense right now, so I'm going to show you a picture. Okay, so there's these 2 blue points. See these 2 blue points? Yeah. Well, this ellipse is centered at 0, 0. These 2 blue points are called foci. Okay, and then we have this red point P that's going to be actual point on the circle. So if you notice right now that the distance, this is what all this means. The distance, that's not what I meant to press. Okay. The distance from focus 1 to the point P is 5.28 right now. So that means from here all the way over here, that distance is 5.28. Okay? And the distance from the second focus to the point P right here is just 0.64. That adds up to 5.92. All right? Now, if you watch this as we go, I'm going to hit draw in a second, and this point right here is going to start drawing an ellipse. Okay? And they're going to have these distances to like this point right here, or like it's going to go all the way around. It's going to follow that point all the way around. If you look over here, this 5.92 won't change. All right? The distances from the focus to the point, those will change. But the sum of those distances will not change. Okay, so let's see this in action. So that sum is always 5.92. All right, so that's what the definition of an ellipse is. It says down here. An ellipse is defined as the set of points P for which the sum of the distances from P to 2 fixed points, foci, is constant. That's the definition. I'm reading it again. That's the same exact thing. An ellipse is defined as a set of points P for which the sum of the distances from P to 2 fixed points, called the foci, is constant. So ellipse is defined as a set of points P for which the sum of the distances from P to 2 fixed points, the foci, is constant. You can have a horizontal ellipse. You can also have a vertical ellipse, and it stays the same. Okay? That makes those foci really important. That's the whole hinging of the definition, those 2 points. Without those 2 points, we can't draw an ellipse. All right? Okay. I'm ready to hit you with a list of properties. That's why your note sheet is blank, because some of you guys write really large, whatever. There's 7 of them. You've seen what an ellipse looks like, so you have an idea. It's an oval shape. After we go through the properties, I'll go through some other pictures so you can look up some more, so you know exactly what I'm talking about. But so you're going to need those properties. All right, here we go. In an ellipse, there are 2 axes of symmetry. What's an axis of symmetry? Yeah, if you have a line and you fold it in half and it's the same on both sides, it's a line of symmetry, right? So in this case, there's 2. One's horizontal and one's vertical. The longer axis of symmetry is called the major axis. Shocking. We'll look at some pictures, but the longer one, like if it looks like it's a horizontal oval, the longer one's horizontal. If it's like a vertical oval, then it's vertical. The shorter axis of symmetry is called the minor axis. Crazy how that works. So you have the major and the minor axis. I mean, this vocabulary, it's crazy. There are also 4 vertices, and those are the endpoints of the axes. I mean, we'll look at a picture in a second so I can point out all these things. You also have the semi-major and semi-minor axis. Both of those are just half of the distance of the axis it's talking about. The semi-major axis is denoted by A. That's going to be increasingly important when we're talking about this today. So semi-major axis is denoted by A. Again, it's just half of the major axis, so you can measure the distance from the center to a vertex on the major axis, and that gives you the semi-major axis. Same thing works for the semi-minor axis, but it's represented by B. It's half of the minor axis, so its distance is from the center to a vertex on the minor axis. And then the last property, each focus, remember we saw the picture, we saw the image earlier, the 2 foci. Each focus is on the major axis. And C, also important, is the distance from the center to one of the foci. So there's a lot of things going on with ellipses. You have major axis, minor axis, the vertices, the foci. We need to keep track of A, B, and C because they're going to be parts of some of the equations we have to use. Once you start working with them, it's not that complicated. But today, you're just going to have a brain full of information. All right, when you're done with your properties, go ahead and change your note sheet over to the back of that page. There's a table we're going to fill out. That way I know you're done with the property. All right. We can come back to that later if we need to. Like I promised, I'm going to show you some pictures before I do anything else. In this ellipse, this is a horizontal ellipse. I know it's horizontal because the distance from D to A is longer than the distance from B to E, right? The longer axis is the major axis. So in this case, it's horizontal. So from D to A is the major axis, and from B to E is the minor axis. That's no big deal. The center, of course, is at the center of both of those axes. They intersect. You have a vertice at the end of each, at the both ends of each axis. So the vertices are A, B, D, and E. Nope. And then you have two foci that are the same distance from the center on both sides. Okay? Then we're talking about A, B, and C as being important variables to know. So again, this is the same exact ellipse. A is half the distance of the major axis. So A is from C to A or from D to C. This distance right here. The B is half the distance of the minor axis, the semi-minor axis. That's from B to C or C to E. It's the same distance. And then you have C, which is the distance from the center to one focus. Again, it's the same for both. You're going to need to know those values, though, today when we're looking at one. So we're going to be building upon this for a few days. So on your tables, we'll start with a horizontal ellipse. The things I have highlighted are highlighted for a reason. The things I have highlighted are the only things that are on the red sheet. And I will not be providing you anything besides what's on the red sheet. That is not a bad thing. Once you start working with them, you'll understand that you don't really have to know anything else to be able to find anything else. It kind of follows a pattern. It's not that big of a deal. I mean, really. You should notice that the equation of an ellipse is similar to the equation of a circle. There's some extra pieces. The same general idea. That means we're probably going to still be completing the square. Probably. We're going to need to know what C is. So it tells you how to find C. It says C squared is equal to A squared minus B squared. That's not the Pythagorean theorem. It is on the red sheet, so you don't forget, though. Some of the terminology is the same, so like the center is still at HK. You don't have to label your ellipse if you don't want to, but you do need to know those equations for the center, the foci, the major axis, etc. All of this is in your textbook too, if you ever need to look back at it and you lose your sheet or whatever. There's also vertical uncircling that. Again, the stuff that's highlighted is the stuff on the red sheet. You don't have to. The diagram. You don't have to draw the diagram. For horizontal ellipse, it's H plus or minus C. And for vertical, it's H k plus or minus c. Yeah, you want to make sure you have those right. You don't want to do all your homework wrong if you've written down wrong. Where? Equals 1. An ellipse is always, the equation for an ellipse is always equal to 1. Notice the only difference in the equations is the a squared and the b squared. They don't always have to be written in that order, but a squared, whatever that number happens to be, is always larger than b squared. So if the denominator underneath the y part is larger than the denominator underneath the x part, then you'll know that it's vertical. If the number underneath the x part is larger than the part of the y part, we know it's horizontal. So, to understand, if you aren't sure of the orientation, there's a question on your note sheet. If you aren't sure of the orientation, you should know that A is greater than B, or also A squared is greater than B squared, always. So the larger denominator should tell you if it's horizontal or vertical. Did it tell the orientation? That's why A squared is under the X for horizontal and it's under the Y for vertical. The larger denominator will tell you the orientation. Does everyone have this filled out? Because we're going to use it in the next problem. If you have an equation, you have two denominators. Let's say you have y minus 3 squared over 25 plus x minus 7 squared over 36. Just because the y is in the front does not make it vertical. You have to look at the denominators. Which denominator is larger? 36. This number is under the x. This large number has to be a squared. Since it's under the x, it has to be horizontal. Right. Right. So RJ just said, well, what if 25 is larger? So if we change this to 4.
The number is larger under the block.
Right. So that's a squared, and so is vertical. The larger number is always a squared. And depending which variable it's under makes it horizontal or vertical. Okay. We're just going to learn target 6 today. That's it. You're going to be given a graph. You're going to write the equation. Find the two coordinates for the foci, and then you're done. You're going to have a picture, though, so it shouldn't be that hard. Yes. It should be the first example on your note sheet. All right. Write the equation of the ellipse graphed to the right in standard form, and then find the coordinates of the foci. So that's afterwards. If you go, I'm just going to go back for a second. First of all, is this vertical or horizontal in orientation?
Vertical.
Vertical. So if you go back and look here at the equation, yes, looking at the equation, I need a K and an H, which is the center, right? And I need A and B, Well, A is the semi-major axis and B is the semi-minor axis. If you have a graph, you should be able to count and figure that out. And then we'll need to know what C is to find the foci later, but we'll come back into that. All right. So we know it's vertical. So I know I'm using this equation. Y minus k squared over a squared plus x minus h squared over b squared equals 1. Everyone's with me. You just wrote it down. We're actually going to fill it in. All right. The center is not identified for you here. It is on one of your homework problems, though. Whatever. So you have two ways of figuring this out. You can either look at the points, like that gives you the vertices. You can use the midpoint formula. You can count. I don't care. What is the center point? -7, 0. You don't flip anything. I'm just writing the center down. The center is at -7, 0. So you could use the midpoint formula. You have -10, 0 and -4, 0. You could find the midpoint between those two. You've got -7, 6 and -7, -6. So you could use the midpoint formula and find it between those two. You could find the center. That is not rocket science, right? We good? All right, so we can put H and K in at least, right? This is H, this is K. Be careful. So I have y minus 0 squared plus x plus 7 squared. I do not have the denominators yet. Everyone good? Make sure you put K where it goes and H where it goes.
Oh yeah, that's sure. Here's 2 points and divided by 2.
Right. All right, I need to know what A is and what B is. A, again, is the semi-major axis. That's from the center to one of the vertices on the major axis. This is vertical, so the major axis is the long one that goes vertically. Right, so I'm counting from the center to one of those vertices. That distance is 6. So A is equal to 6. So A squared is then 36. Everyone go with that. B is the semi-minor axis. The semi-minor is half of the short axis that goes horizontally in this case. So how long is that? 3. From here to here, that's 3. So then we have 9. 3 squared. No, it's squared. So it can't be negative. That's your equation. That's it. Because the distance from the center to one of these vertices is 3. Like from -7 to -4 is 3, or from -10 to -7 is 3. Now, this could be written to several ways. You can leave it like that. You will probably see it not with y minus 0. You'll see y squared over 36 plus x plus 7 squared over 9 equals 1. Or, like I said earlier, it doesn't have to be written in that order. So you could see x plus 7 squared over 9 plus y squared over 36. You're going to see that way a lot because they like to put the x first. How would I know that bottom one is vertical? The greater denominator is 36 and it's under the y. Right? Everyone good? So I found the equation, but then it says to find the coordinates of the foci. Okay? There's an equation for that. H, comma, K plus or minus C. Right? We need to know what C is then. There's an equation for that too. C squared equals A squared minus B squared. Not the Pythagorean theorem. Don't add them. So c squared equals 36 minus 9. So c squared equals 27. So c equals the square root of 27, and you can leave it that way if you must. But you could rationalize that because 27 is 9 times 3. So that's also 3 times the square root of 3. Right? That's just arithmetic. You guys can figure out c, right? Then we just go back and write the actual foci. So h in this case was what, negative 7? So you have negative 7, and then 0 plus or minus 3 square root of 3. There's going to be 2 foci, right? So one of them is at negative 7, 0 plus 3 square root of 3. And one of them is at negative 7, 0 minus 3 square root of 3. If you had not a 0 there, it was like a 4 or something, you could just leave it like this. You could have like 4 plus 3 square root of 3. I'm okay with that. That's an exact answer. In this case, we have 0, so we can simplify that if we really wanted to. But most of the time, you're going to have some other term. You're going to have like 5 minus square root of 2. That's okay. Just leave it that way. In this case, we had zeros, though, so it was easy. So those are your 2 points for your foci. Do you think you can handle that on your homework? You have 3. You're writing equations and finding the foci, just like we just did from a graph. I think you'll be fine.